In this demo, we will go over the effect of spring variation on the period and amplitude of simple harmonic motion. More information about oscillations can be found on pages 116 through 123 and pages 353 through 363. Now let's get started. The materials we will need are some springs. Here we have 5 different springs that are theoretically the same length, but have different spring constants. A spring constant is the force needed to make the spring oscillate, the force per unit length. Here, the red spring requires the least force, while the green needs the most. Some other materials we will need are a spring hook and ring stand, a meter stick, a 500-gram mass, and a timer. We also suggest having tape nearby to secure the setup. For the setup, you want to place the ring stand on a table or counter edge. At this point, we want to use the tape to secure the spring hook onto the ring stand so it doesn't shake during the demo. Then hook one of the springs onto the spring hook and measure the distance between the bottom of the spring and the ground. Then attach the mass at the bottom and measure the distance between the bottom of the spring and the ground once more. If at this point the ring stand is leaning or falling off the edge of the table or counter, get some extra weight to put on the other side of the ring stand. Now that we have all the materials and know the setup, let's get started. Here we are starting with the red spring, which has a spring constant of 25 newtons per meter. It starts at 92.3 centimeters off the ground and drops to 79 centimeters. To find the amplitude, we take the difference between the measurements and divide that by 2. Therefore, the amplitude for this red spring with the 500-gram mass is 6.65 centimeters. To find the period, the spring has to start at one point and end at the same point. So if the spring were to start at the top, it would have to go all the way down and back up to complete the period. The period takes 0.87 seconds. Next, we have the blue spring with a spring constant of 30 newtons per meter. The amplitude of this spring is 6 centimeters with a period of 0.8 seconds. Then we have the yellow spring with a spring constant of 35 newtons per meter. The amplitude of this spring is 3.55 centimeters with a period of 0.74 seconds. Then we have the white spring with a spring constant of 40 newtons per meter. The amplitude of this spring is 4.35 centimeters with a period of 0.63 seconds. The white and green springs start to bounce around as they oscillate, as the mass is not heavy enough for the springs to oscillate at an even constant rate. Lastly, we have the green spring with a spring constant of 50 newtons per meter. The amplitude of the spring is 2.95 centimeters, with a period of 0.66 seconds. From this demo, you should have seen how springs with different spring constants have different amplitudes and periods. The higher the spring constant, the smaller the amplitude and the shorter the period. However, in this demo, there may have been a systematic error with the white spring at a 40 newtons per meter spring constant, as it had a shorter period than the green spring at 50 newtons per meter. The white spring also had a larger amplitude than the blue spring at 30 newtons per meter. But when comparing the yellow, blue, and red springs, everything seemed to go well. The yellow spring at 35 newtons per meter had the shortest period and smallest amplitude of the 3, while the red had the longest period and the largest amplitude.